Hello everyone. Today we will learn about the sustainable product life cycle in green technologies. Myself is Monisha Agratna from BTech Biotechnology in Erode Singundar Engineering College. Let's we see about introduction of sustainable product life cycle. Let's see what is sustainable product life cycle. They are refers to the holistic and strategic approach to managing products so that their environmental impact is minimized at every stages. Unlike traditional methods that focus only on protection and sales, this approach look at the full life cycle. There are raw material sourcing, product designing, manufacturing, transportation, consumer uses, disposal or recycling. Then core objectives is referred as reduced carbon emissions, conserve energy and water, use fewer raw materials, promote recycling and reuse, support circular economic principles. Why green technologies matter in this world? They are green technologies are increasingly important because the world faces seriously environmental challenges such as climate changes, pollution, and resource depletions. First of all, consumer demand. There are modern consumer prefer brands that prioritize sustainability. Then emission reduction. Emission reduction is referred as green technologies can significantly reduce greenhouse gas emissions. Then finally, economic opportunity. There are sustainability creates new markets, industries, and innovation opportunities. This shows that sustainable is no longer optional; it is becoming a competitive and a social necessary. Let's see five life cycle stages. These five is major type of sustainable product life cycle. First one, design. That is referred as sustainable begins. Important design including product functionality, material selection, energy efficiency, repairability. That is mainly referred as poor design choice can create long-term environmental issue. Second one, manufacturing. That is referred as this involves converting raw materials into finished products. That is efficiency, energy use, waste reduction. Clean cleanser technologies. Third one is distribution. That is referred as product must be transported and packaged. Sustainable logistic reduce fuel use and emissions. Fourth one, usage. This usage is referred as consumers interact with the product. There is efficiency, durability, and a responsible use are critical. Finally, end of the life. That is referred as recycling, reuse, and disposal of the manufacturing product. Then, first phase is design phase. Actually, previous slide is a shortly definition. I will provide short definition, but this slide I will explain it detailed. Design phases. The design phases conserved the most influently stages because it determines many future environmental impacts. First one, eco design. That is, eco design integrates sustainability into product creation. It considered reduced energy consumption, low material usage, easy repair and disassembly. Then material selection. Choosing sustainable material improve environmental performance. Example, renewable material, recyclable components, non-toxic sustainable. Then innovation. That is, designers create produce that last longer, use fewer resources, produce less waste. The design phase sets the direction for the entire life cycle. Life cycle assessment. What is LCA? LCA is scientific method used to measure environmental impact. It examines every stages of product's life. There are four major steps involved in LCA. First one, goal and scope. Second one, inventory analysis. Third one, impact assessment. Finally, interpretation. First one, goal and scope is referred as determine what is being studied and why. Innovatory analysis is referred as collect data on energy, material, and emission. Third one, impact assessment is referred as evaluate environmental consequence. Finally, interpretation. It is referred as analyze finding and suggest improvements. Uh, Benefits of LCA in sustainable product. LCA helps company identify problem areas and make informed sustainability decisions. It supports certification and improves transparency. Let's see. Which type of materials used in the sustainable product manufacturing? There are these five major materials used in the sustainable product manufacturing. First one is bioplastics. Bioplastics is majorly source of corn, sugar cane, algae waste. And this bioplastic is majorly used in this world, biodegradable product and then renewable energy sources. Recycled metals is mainly source of post-consumer waste. This is used as 90% energy saving. Then bamboo. Bamboo is the one of the most important in the sustainable product manufacturing because bamboo is a natural product. There are bamboo is intake the carbon dioxide and then outlet of oxygen gases. Mycelium. Mycelium is mostly recovered from the fungal network. This is a help of environmental. They are compostable packaging. Then ozone plastics. Ozone plastics is referred as marine debris recovery. For example, some waste products to throughout the ozones. That products is refunctioned and then restructured that waste products some that waste products usually some functions for example waste reduction. Then manufacturing phases. This is resource efficiency and clean production. First one, energy optimization, waste minimization, water management, and emission control. First one is energy optimization. This is required as using renewable energy and efficient system. For example, renewable energy interaction, heat recovery system, smart grid technology. Then second one, waste minimization. This is reducing scrap and reuse byproducts. For example, zero waste manufacturing, industrial symbiosis, byproduct utilization. And third one, water management. It is mostly required as treating and recycling the water. For example, closed loop system, wastewater treatment, rainwater harvesting. Finally, emission control. Emission control is mainly referred as lowering greenhouse gases and pollutants. For example, carbon capture, air filtration, green chemistry. Let's see, green manufacturing technologies. These four technologies mostly used in green manufacturing. First one is 3D printing. 3D printing is helpful of reducing waste by using only required materials. Then AI and IoT, artificial intelligence and Internet of Things. These are a monitor operating in real time. Then robotics. Robotics is mainly used as increasing precision and reduce errors. Then biotechnologies. Biotechnologies mostly used in produces eco-friendly materials with using biological. Then distribution and logistics. First is sustainable strategy. These are road optimization, electric vehicles, local sourcing, reverse logistics. They are packaging techniques, reducing unnecessary material and using eco-friendly alternatives. This stage ensures product move efficiently with minimal environmental cost. Their route optimization is referred as AI power delivery planning. In electric vehicle is zero emission transport, for example, e-vehicle. Consolidated shipping is meant by reduced trips and fuel use. For example, control the petroleum. Local sources referred as minimized transport distance. Reverse logistics is majorly used as product returns and recycling. Let me see about carbon footprint in transportation. With the different transport modes vary in emissions. They are average emission per ton kilometer. These four is majorly used in carbon footprint. First one, air freight, road, rail, sea freight. These are these values in the average emission per ton kilometer with relative vary transportations. They are air freight is the highest value for the transportation, then sea freight is the lowest value in the transportation. Let me see about consumer use space. This is largest and most impactful stage in sustainable product manufacturing. These three phases is majorly important in the consumer use space. First one is energy efficiency, then durability, then user behavior. First one, energy efficiency. This is mean by the product have which kind of energy. For example, energy store rating, smart power management, low standby consumption. Then durability. Durability is mean by product life cycle. For example, quality materials of that product, modular repairs, expanded warranties of the products. Then user behavior. User behavior is important in the consumer use space. This is mean by interaction between the consumer and the product. For example, eco mode setting, maintenance guidance, sharing economy. Then product longevity strategy. These are four is major in this step. First one, design for durability. It is mean by reinforced components and quality testing. Second one, modulatory. Modulatory is mean by replaceable parts and upgradable systems of the products. Again, repairability. Repairability is mean by we replace the product with later their functions and then their structures. Their example to free access, spare parts availability. Then software support is mean by long-term update and backward compatibility. Then easily detect the error. Let's see end of the life management. This is for reuse majorly used in the end of the management. First one is reuse. Reuse is a product resale and donation. This is mostly helpful of 100% value retention. Then refurbish. Refurbish is mean by repair and resell the products. This is help us 80 to 90 percentage of value retention. In remanufacturing is mean by complete rebuild the product functions. This is help of 70 to 80 percentage value retention. Recycle is mean by material recovered from waste product. This is help for 30 to 50% value retention. They are reuse is the mostly powerful in the end of the life management because this is 100% value retention is provided. Circular economy model is mostly referred as linear and then circular. Linear is mostly incorrect of the sustainable product manufacturing because take, make, dispose. This process is mostly preferred as industry manufacturing, but circular economy is mostly preferred as system manufacturing, and then we consider as industrial manufacturing. First of all, design, use, return, regenerate. Linear economy is mostly single use of the product, but circular economy is multi uses of the product, that is reuse or recycle such. Core principle of this circular economy model is designed out based in the system based on the equipment based, then keep material in usage, then regenerate natural systems. E-waste management. Global faces issues the many challenges of e-waste management. First of all, 53.6 million tons generated annually, in only 70.4 percentage formally recycled, contains valuable materials worth pay 57 B dollars. Toxic substance harm environment. Then solution of the challenges, extended produced responsibilities for us, EPR, take back programs, urban minimum initiatives, certified recycling facilities. There are electronic waste is one of the fast growing waste streams. It contain value metals, hazardous chemical. Proper system are needed for recovery and safe treatment. Policers, searchers, producers' responsibility improve accountability. For example, gold 7% of global mining, silver is 15% of global mining, copper is 22 million tons, rare earths is critical for tech. Real case study in this world for sustainable product manufacturing, there is Tesla electric vehicles is first will design the product with the using system, then manufacturing the products, then use the consumers, then end of the life of the product. First design is minimalist design for efficiency, recyclable aluminum body, then long range batteries. Then manufacturing is Gigafactory solar resource, a battery recycling program, water recycling system. Then usage is customers, zero tailpipe emissions, OTA software updates, superchargers network, then end of the life of the product, battery second life storage, 95% material recover with reuse or recycle, closed loop recycling. Then another case study is Patagonia clothing that is committed to sustainability, 1% for the planet member, 100% renewable energy, fair trade certified, organic cotton only. Won't wear program, buyback, repair and resell used garments to extend product life and reduce waste. These are renewable energy, fair trade. It is improve that environmental commitment can strengthen bad values. This is impact of material 87 percentage or recycled, repair of the 50,000 plus items annually. Emissions is 76 percentage reduction. Mostly, which challenges we will face with those? A high initial cost, lack of infrastructures, limited awareness, complexity, supply chains, and regulatory difference. Then certification and then standard. Certification of standards verify sustainability chains. So for example, ISO 14001 is environmental management system. Then energy storage, energy efficiency standard system. Then cradle to cradle is circular product design management system. LEED is green building certification of the systems. Then B crop is social and environmental performance, for example, biological system. Then fat trade is ethical supply chains. Role of technology in sustainability. There are four technology is mostly used in sustainability. First one, AI, artificial intelligence, then blockchain, then IoT sensor, then big data analytics. AI is mostly used as predictive maintenance and supply chain optimization, then energy management. Blockchain is mostly used as supply chain transparency, carbon credit tracking, circular economy platform. Then IoT sensor is mostly used as real-time monitoring, resource tracking, smart manufacturing. Then big data analytics is most important in the sustainability. It is helpful of life cycle assessment, impact modeling, waste prediction. Then see future trend and innovations. These five trends is boom in sustainability product manufacturing. First one is carbon negative products. Second one is bio-based electronics. Then third one is autonomous recycling. Fourth one is digital product passports. Finally, regenerative materials. Carbon negative products is mean by used as carbon products. Then the products is mostly helpful in the consumers. Then bio-based electronics is mostly biodegradable e-wasters. Then autonomous recycling is mostly AI powered. AI powered. This products is more recycling. Then digital product passports is mean by blockchain based life tracking. Regenerative materials reuse or recycling the product with using biological products. Best practices for organization in the sustainable product. There are four is majorly used in the organization practice. First one is strategic planning is meant by science-based target LCA for all product sustainability KPIs. Then operational excellence is mean by green manufacturing implementation, optimization, optimizes supply chain, reduce the waste. Stakeholder engagement is mean by transparent reporting, customer education, supplier collaborations. Then innovation culture is mean by R&D for eco design, employee training, open innovation partnerships. These four practices majorly used in sustainable products. Additionally, one practice is mostly involved in the organization, that is train employee. That is, the product will manufacture will depend upon the employee. The employee will create some error. The product is mostly failure product. The employees create the product with perfect structure and then perfect functions. That product is very useful in their consumers. Together we can make a difference. The which type of product we will use the learn about in the slide. First one, choose sustainable products, our daily usage. Then support circular business models. Then advocate for green policies. Then invest in innovations of the sustainability product. Thank you for all.